In the beginning of this series, I made the challenge. I said I tried to do the average, do some sort of calculation on a big file in Excel, and it wouldn't do it. Excel can't accept over a little bit over 1 million numbers. And I made the claim that C could do this no problem, and this video, the program we're going to write in this video actually achieves that. And so this is kind of one of those milestones that sort of proves to the listener here, the viewer of these videos, that yes, C is a useful thing to learn. Programming in general is very useful. And so it's going to be a very, very slight change from the previous program, average_argv. So let's take that folder, make a copy of it, and then change the name of that to average_big for big numbers, for big data files. We're going to go into that folder, erase the executable, and change the name of average_argv to average_big.c. I need to do two other things. I want to add bigger files, and so I go into my data folder and I get the O1m and O10m.txt files. That's 1 million and 10 million numbers. So we could do a 1 million number file and a 10 million number file in this example. Then I double click on average_big.c and it should come up in Notepad++, no problem. The main thing we're doing in this program is we're changing the variable types. So right now we have ints and floats. But if we do 10 million numbers or even bigger, this is a computational science issue, is the size of the variables that we did may not be big enough. Ints can go from minus about 32,000 to plus about 32,000. That's the size of an integer. It's a certain number of bits, and so it can only handle a certain size. A floating point number is the same way. It can only handle a certain number of decimal points after the period. So we need bigger versions of those. A bigger version of a floating point number is a double, D-O-U-B-L-E, double. So I'm going to change all my floats to doubles. And a bigger version of int is a long int, long space int. A long integer can go from about minus 2 billion to plus 2 billion. A little side item on computational science. I mean, you can do long ints. You can do unsigned because they only have positive numbers. So you can go from 0 to 4 billion instead of minus 2 billion to plus 2 billion. So there's all sorts of ways to make bigger numbers and to do much, much bigger calculations. It's a thing. So computational science is a field of study. And so to become good at doing big time data analysis, there's a lot of computational science type issues, not computer science, but computational science stuff. Math people and engineers do this kind of stuff all the time. So, but we're not going to go nuts here. We're just going to change all our floats to doubles, change all our ints to long ints. It has an impact on all the scanf and printf statements. All the percent characters have to change to reflect that. So that's going to be another change that we're going to see. The other thing that's important is we could have an array with 10 million numbers in it, but that's actually memory within a C program is a thing as well. That's the thing that you need to know for computational science. When we're dealing with small numbers and small data files and all that stuff, it's never an issue. Modern computers are really, really big in terms of memory. But once you get into big data sets, the memory available for your computer actually could become an issue. It turns out we don't need to save all those numbers. We just need to use one once and then throw it away and then go to the next one and use that one and add that one to the sum. We can use a temporary variable, not an array, in this program, and that's what I'm going to do. I changed double A brackets 1000, square brackets 1000, to just a variable temp. We're just going to do it as a temporary variable. Not as a we're not going to store the 10 million points in our program. Good? All right, so those are the main changes that we're going to do to the code. And the other thing that's really important that we're going to do is we're going to combine the two loops. There was one loop to load the data and then one loop to calculate the sum. We're going to do it all in one loop. This way you don't have to store the data. So before the while loop, while fscanf loop, I set sum equal to 0 and I equal to 0. And then inside that loop, in addition to incrementing I, before we increment I say sum equals sum plus temp. Right? So now we're just, when we go through the first number, temp, the first number is stored in temp, then right after we retrieve temp, we add it to sum. Then we go back, we store a whole new number in temp, we add that to sum, and so temp only carries the value of the latest number in that big file that we had. Good? That's it. That's all we had to do to change it. So there's no second loop there. We just added the sum up there. Make sure you put sum equals 0 above that while loop. It's always important to zero out your sum before you start adding stuff to it. And those are the big changes. Notice that in the fscanf statement, we're doing an LG, long float. And when we're printing out numbers, we're printing out LD for long decimal number and LF for long floating point number. Okay, so those are the changes in the printf and the scanf statements in terms of the percent variables. I think that's it. I think that's everything we have to do. So now we save it, Control S, and then we have to go into the command prompt. So I go down to the search bar to CMD, I get the command prompt, I bring it up. If you notice lately, I think in the last 2 videos, I had to do CD space OneDrive first because my desktop has been synced with my OneDrive. And so earlier videos that wasn't the case, and now it is the case. So many of you probably have that same step you've been doing since the beginning. And so I do CD OneDrive, CD desktop, CDC code. Then I go into CD average underscore big. And then I compile the program. And again, this is an argv, so I'm just going to input the data files in there. I'm going to do the small data file first, 010. Then let's do the million data point file. Average underscore big 01m.txt. Boom, comes up no problem. And let's do the 10 million one. So I do underscore average underscore big space 010m.txt. Remember, this is impossible to do in Excel. I press return. It does take a few seconds to do, so you're going to watch it. It's going to sit there and calculate for a few, depending on your which type of computer you have. If it's a super fast computer or super slow computer, it can be anywhere from a couple seconds to maybe 6 or 7 seconds. It depends on I think it depends on the access time of your drive too. So if you have a fast drive versus a slow drive. Anyway, so after 6 seconds or so or less, it comes up. This is something that we weren't able to do at all with the tools we have. And now we have a tool that can do it and do it no problem. We can go up to 1 billion points with this same program, right? We have you're just using long ints and doubles, we can go up to 1 billion points. Wow. So much more powerful C programming is than off-the-shelf tools. And they're fast. And the programs that you write for them are able to do big-time calculations very quickly. It's a powerful tool. I'm done trying to convince you that this is a worthwhile effort to go through all these videos. It is, believe me. Yeah, to be able to do something this big, this fast, it's easy. And it did, to be honest, it didn't take us that long to get to this point. You know, we learned a lot of things on the way, but, you know, it was super fast to do that. And now we're going to start adding even more tools and learning even more to become more powerful programmers.